So in this video, we're going to cover divisibility rules. So before we get into it, let's get into a basic definition of divisibility. So a number is divisible by another number if when you divide them, you get a remainder of 0. So for example, is 27 divisible by 3? It is, because 27 divided by 3 gives you 9 with nothing left over. How about 34? Is that divisible by 6? It's not, because when you do 34 divided by 6, it gives you 5, but with something left over. So simply what divisibility rules does is it allows you to quickly figure out what number divides into other numbers easily. Okay? Now all of these rules can be proven through algebra, but all we're going to do is just go through the rules and show you how to use them. Let's look at the easiest rule, the divisibility rule for 1. All whole numbers are divisible by 1. In other words, you take a number, you divide it by 1, it's equal to itself with no remainder. So in other words, is 8 divisible by 1? It is, because 8 divided by 1 gives you 8 with no remainder. Same thing with the other one. 5,397 divided by 1 gives you that same number, but with no remainder. So we're just going to move straight to 2. Let's look at the rule for 2. So to be divisible by 2, the number has to be even. In other words, it has to end in 0, 2, 4, 6, or 8. You're used to this when you count by 2's. So this makes this rule very easy to remember. So is 3516, is that divisible by 2? It is, because it ends in 6. That means it's even. How about the second example? Is 2847, is that divisible by 2? It's not, because it ends in 7. That means the number is not even, so 2 doesn't go into it. So we're going to move straight to 3. For the rule for 3, you just add up all the digits, and the total has to be divisible by 3. So for example, is 24 divisible by 3? It is, because when you add up the digits, it adds up to 6, and 3 divides into 6 evenly. How about for the next example? Is that divisible by 3? It is, because when you add up the digits, that gives you 15, and 3 does divide evenly into 15, so therefore 3 goes into 6,702 evenly. How about the last example? Is that divisible by 3? It is not, because those digits add up to 11. 3 does not evenly divide into 11, so therefore 3 doesn't divide evenly into 3,335. Let's move to the rule for 4. For the rule for 4, you're not adding anything. You're just looking at the number made from the last 2 digits and checking to see if it's divisible by 4. Looking at the first example, it is divisible by 4 because the last 2 digits make the number 16 and 4 divides into 16 evenly. Looking at the second example, the last 2 digits form the number 8. 4 does divide into 8 evenly, so it also divides into the big number as well. Looking at the bottom example, the number made from the last 2 digits is 42. 4 does not divide evenly into 42, so 4 is not going to divide evenly into the big number as well. Sometimes it can be tough to tell if a number is divisible by 4 from the last 2 digits. So sometimes you may have to do a little bit of long division to check for divisibility. Let's look at this example. The last 2 digits form 92. Not everybody can tell if 4 divides into 92 evenly, so we'll have to do long division. Looking at the division, you don't get a remainder, so it does look like 4 divides into 92 evenly, so 4 will also divide into the big number evenly as well. One last point that I'd like to make about this rule is that numbers that end in 00 are always divisible by 4. Let's look at an example. For example, when we look at the number 37,900, the last 2 digits make 0. And yes, 4 does divide into 0 evenly because 0 divided by 4 is 0 with no remainder. So therefore 4 will also divide evenly into 37,900 as well as all numbers that end in 00. The rule for 5 is very easy. The number just has to end in 0 or 5. You're used to seeing these numbers when you count by 5's. So let's look at the first example. Is that divisible by 5? It is, because it ends in 0. How about the next example? Is that divisible by 5? It is, because it ends in 5. How about the last example? Is that divisible by 5? It is not, because it ends in 2 and not in 0 or 5. So the rule for 5 is pretty easy. Let's move to 6. For the rule for 6, A number has to be divisible by 2 and 3 at the same time. So as you can see, I've put the rules for both 2 and 3 up top so you can follow along as we work through these examples. For the first number, it is definitely even, so it's divisible by 2. And when you add up the digits, it adds up to 18. 3 does divide evenly into 18, so it's also divisible by 3. Since it's divisible by 2 and 3 at the same time, it is also going to be divisible by 6. Looking at the second example, it is even, so it's definitely divisible by 2. However, when you add the digits add up to 20. 3 does not go into 20 evenly, so it's not divisible by 3. So since the number itself is not divisible by 2 and 3 at the same time, it is not going to be divisible by 6. How about the next example? Looking at this number, it's divisible by 2 because it ends in 0, and when you add the digits, it adds up to 15, and 3 does go into 15 evenly. So therefore the number is divisible by 2 and 3, so therefore it's divisible by 6. Looking at the next example, it is not divisible by 2 because it's not even though when you add the digits do add up to 12, so it is divisible by 3. But since it's not divisible by 2 and 3 at the same time, the number is not going to be divisible by 6. The rule for 7 is not as hard as it looks. All you do is multiply the last digit by 2, subtract it from the rest of the number, and that answer you get has to be 0 or divisible by 7. Let's look at an example. Looking at 364, you multiply the last digit by 2, that will give you 8. You subtract it from the rest of the number, which is 36. Subtracting those two answers, you get 28. Now you check 28. 7 does divide evenly into 28, so therefore 7 will divide evenly into 364. Looking at 717, once again we multiply the last digit by 2, that gives you 14. Subtracting it from the rest of the number, which is 71, you end up with a final answer of 57. Now we check that. 7 does not divide evenly into 57, so therefore 7 will not divide evenly into 717. Looking at 105, we multiply the last digit by 2, you get 10. You subtract it from the rest of the number, which is 10, you get an answer of 0, and then we check it. Yes, we did get 0, so that means 7 does divide evenly into 105. Sometimes it's hard to tell if an answer is divisible by 7, so you can repeat the rule over and over again to check for divisibility. Let's look at 3,546. Multiplying the last digit by 2, you get 12. Subtracting it from the rest of the number, which is 354, you get a final answer of 342. 342 is not the easiest number to check to see if it's divisible by 7, so we're going to use the rule again, but on 342. Checking 342, you multiply the last digit by 2, which is 4. Subtracting it from the rest of the number, which is 34, you end up with a final answer of 30, which is easier to check for divisibility. 7 does not divide evenly into 30, so therefore 7 will not divide evenly into 3,546. Looking at the rule for 8, the number made from the last 3 digits must be divisible by 8. You're not adding any digits, you're just looking at the number made from the last 3 digits. Looking at the first example, the number made from the last 3 digits is 800. 8 does divide evenly into 800, so it divides evenly into 4,800. Looking at the next example, the number made from the last 3 digits makes 56. 8 does divide evenly into 56, so 8 divides evenly into that big number. Looking at the next example, the last 3 digits make 9. 8 does not divide evenly into 9, so 8 will not divide evenly into 6,009. Looking at the last example, the number made from the last 3 digits is 78. 8 does not divide evenly into 78, so 8 will also not divide into that big number as well. Sometimes it may be tough to tell if a number is divisible by 8 just by looking at those last 3 digits. So sometimes you may have to do a little bit of long division. Looking at the example below, we see that the last 3 digits form 388. Obviously, some people can't tell if 8 goes into 388 evenly, so we'll do long division on it. we see that we do have a remainder, so it doesn't go into it evenly. So 8 will not go into evenly the big number either. The last point I'm going to make is that numbers that end in 3 zeros are always going to be divisible by 8. Looking at the number 21,000, the last 3 digits make 0. 8 does divide into 0 evenly because you get 0 with no remainder. So therefore 8 will go into 21,000 evenly, as well as all numbers that end in 000. To be divisible by 9, you just add up the digits, and the total has to be divisible by 9. So is 36 divisible by 9? Yes, it is, because when you add the digits, you get 9, and 9 divides into 9 evenly. In fact, when you go through your 9's times tables, if you add up all the digits of each of those answers, they add up to 9, and so all of those numbers are divisible by 9. Is the next example divisible by 9? It is, because when you add those digits, it adds up to 18, and 9 does divide evenly into 18, so it also divides evenly into the big number as well. Looking at the last example, those digits add up to 28. 9 does not divide evenly into 28, so it will not divide evenly into the big number as well. Lastly, to be divisible by 10, the number just has to end in 0. And notice when you count by tens, they all end in 0. So this is a pretty easy rule to remember. The first number is divisible by 10 because it ends in 0, and the other two numbers will not be divisible by 10 because they don't end in 0. And that pretty much covers all the divisibility rules. Now that we're done, you can do something more useful with your time, like iron your clothes, because you don't want to walk outside looking like crumpled paper. Like and share. Math on the fly. Laters.